All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about the Graham's law of diffusion. Please, if today is your first day of watching our video, please consider subscribing. All right, now let's talk about what is diffusion. Diffusion is the movement of particle from the region of the higher concentration to the region of lower concentration through a permeable membrane. So now, please do not confuse diffusion with effusion. There's a difference between diffusion and effusion. All right. So now, right, effusion is the escape of gas from a tiny hole. Okay. Effusion is the escape of gas from a tiny hole. You need to know that. Now, let's write. Graham's law of diffusion stated that the rate of diffusion of gas is inversely proportional to the square root of its density. Okay. Or vapor density. To the square root of heat density or vapor density of the gas, provided that temperature and pressure remains constant. All right. This means that the rate of change of diffusion of a gas increases with the density or weight of the gas. Decreases. Okay. Note, lighter gas diffuses faster than heavier gas. In other words, gases with small relative molecular mass diffuses faster than gases with higher relative molecular mass. So mathematically, let's talk about this mathematically. Okay. Graham's law of diffusion states that the rate of change of diffusion, let's call it R, is inversely proportional to the square root of its density. Okay. Or let's use D as density. Let's just use D as density. All right. So we now have that R is equal to what? K over what? Square root of D. So therefore my K is equal to what? R the square root of D. So we have that R1 the square root of D1 is equal to R2 the square root of D2. Where, very important, you must tell them that where R is equal to what? The rate of change of the rate of what? Diffusion. The rate of diffusion. Rate of diffusion. Right? Where D is what? Density. No, density is supposed to be rho, but let's just use D as density. Then our K is proportionality constant. Proportionality constant. All right. So this is the one of the important formula to note for Graham's law of diffusion. Right. So the next thing you need to know, let's consider the rate of two gases A and B. Can I clean here? Let me clean here. Okay. Or let me write it there. Okay. All right. So let's just look at this. But we know that density or vapor density is directly proportional to the relative molecular mass. Okay, therefore, Graham's law of diffusion can be restated as follows. Okay, he states that at constant temperature and pressure, that the rate of diffusion of gas is inversely proportional to the square root of the relative molecular mass. Please, that one is another important one that is very, very important. Okay, it's very, very important. So you have that the rate is inversely proportional to the square root of the relative molecular mass. Right. So therefore rate is equal to what? K over the square root of the relative molecular mass. So we now have that K is equal to what? R the square root of what? The relative molecular mass. So you can call it what? R1 the square root of relative molecular mass 1, okay, is equal to R2 the square root of what? The relative molecular mass 2. Okay, this is another important formula that you need to note. Okay, so So another thing you should note that okay, where R is the rate of diffusion of gas and R dot M is the relative molecular mass, right? So note that rate is equal to what? Volume over time. Rate is equal to volume over time. Rate is equal to volume over time. Note, you should know that rate is equal to what? Volume. Volume over time. So if we use the rate is equal to volume over time, we will now have that okay. If we have the rate is equal to volume over time, it shows that okay, that rate is inversely proportional to time. That is what it's showing. The rate is inversely proportional to time. So we should have that what? Very important formula that that uh, am I using? Should I use density? Okay, if we use density, we will know that since rate is inversely proportional to time, we have that R1 all over what? Sorry, R1T1 is equal to R2T2. Another important formula to note. Okay, R1T1 is equal to R2T2. Okay, then, or you can equally say that what? Let me clean here. You can equally say that what? That you know that you can equally use this. You can equally use that what? The square root, that T1, the square root of what? Relative molecular mass 1 is equal to what? T2, the square root of relative molecular mass 2. Okay? This is another important formula you need to note before we start solving some calculations. Now, before that, you need to know that what factors affecting Graham's law of diffusion. Number one is mass, number two temperature, number three pressure, number four density. So now let's talk about the graphical representation of the rate of diffusion of gas graphically. So graphically, we have done mathematically. So graphically, we have that if we are plotting the graph of the square root of d against r, okay, and this r is measured in what? Cm cube per sec. Cm cube per sec. While density is measured in what? Gram per cm cube. Gram per cm cube. So they say that the graph is like this. Okay, the graph is like this. So but if you are plotting the graph, if you are plotting the graph of 1 over this, if you are plotting the graph of rate, if you are plotting the graph of rate in what? In cm cube per sec against 1 over the square root of d, okay, in cm cube per gram. So you now have that it will not be a straight line graph. It will not be a straight line graph, okay. So that is that. So now the above graph shows that the rate of change of diffusion increases as the reciprocal of the square root of this increases as well. So but if you are plotting it against this, as the other one is increasing, the other one is equally decreasing. So let us solve some calculation to illustrate that, then we are good to go. Okay, calculations involving the rate of change of diffusion of a gas that is inversely proportional to the square root of its density. So number one said at constant temperature and pressure. Number one said calculate the rate of diffusion. Calculate the rate of diffusion of 200 cm cube of hydrogen. 200 cm cube of hydrogen hydrogen gas in 30 seconds. In 30 seconds. All right. Solution. I told that rate is measured in cm cube per sec. If you remember that is cm cube per sec, you now know that rate is what? Volume. Volume over time. Okay, so the volume they gave us is 200 cm cube and the time they gave us is 30 seconds. So if you do the two of them, you're going to have 6.67 cm cube per sec. Okay, very, very simple. So the next question, question number two. Question number two. Question number two said, calculate the rate of diffusion. Calculate the rate of diffusion of 500 cm cube of a gas in an hour in dm cube per sec. Solution. Okay, they are the one that told us to calculate this in dm cube per sec. So what do? They gave us an hour, so the time is 1 hour, and 1 hour is 60 times 60. To convert it to seconds, that is 3600 seconds. Okay, but they gave us that the volume there is 500 cm cube, which is what? 500 divided by 1000 to convert it to dm cube. So I have 0.5 dm cube. All right, so what do you do next? So we now have that the rate of diffusion is equal to what? Volume over time, which is equal to what? 0.5 divided by 3600. So what do you have? 0.5 divided by 3600. You have 1.39 times 10 raised to the power what? Minus 4 dm cube per sec, according to what they told us to convert it to. That they need it in dm cube per sec. All right, so let's move to the next one. The next question said, which of the gases, number 3, which of the gases gases H2, N2, Cl2 and CH4, okay, would diffuse faster when passed through a porous pot. All right, okay. Solution. The first thing we need to get is their relative molecular mass. The relative molecular mass of H2 is equal to 2 into H, which is equal to what? 2 into 1, which is 2. Okay, the relative molecular mass of nitrogen, Ne2, is 2 of N, which is 2 of 14, which is 28 gram per mole. Please, gram per mole. Okay, so the next one is the Cl2. The relative molecular mass of Cl2 is 2 in bracket of Cl, which is 2 in bracket of 35.5, which is equal to what? 2 times 35.5 will give us where is it? That is, I think, 71. That is 71 gram per mole. Okay, and the last one is what? The relative molecular mass of CH4, which is what? C plus 4 into H, which is equal to what? C is 12 plus 4 into 1, which is what? 16 gram per mole. Okay, so, and you know that what? That the rate of change of diffusion is inversely is inversely proportional to the what? The relative molecular mass. So anyone that has a smaller relative molecular mass will diffuse faster. So hydrogen will diffuse faster than any other gas listed here, right? So the answer is is hydrogen. Hydrogen is the one that has the least relative molecular mass. So, and that is the one that will diffuse faster. So the next question, question number 4, question number 4 said if it took 120 seconds for 100 cm cube of O2 to diffuse, all right, and okay, they say another gas, comma, another gas X of equal volume took 170 seconds to diffuse. Okay, then as under the same condition, under the same condition, then as they calculate a the rate of change, the rate of diffusion of the two gases. Number B, calculate the relative molecular mass. Calculate the relative molecular mass of the second gas, the second gas X. Okay, very simple solution. So first of all, we know that the rate is equal to what? Volume over time, which is what? The volume is what? 100 divided by the time, 120. So 100 divided by 120, what do you have? That is for oxygen, the rate of oxygen. Okay, that's the rate of diffusion of oxygen. So what do you have? You have 0.83 cm cube per sec. This one is the rate of diffusion of oxygen. So let me write it O2 here. So but the rate of diffusion of gas X is equal to the same volume but different time. So what do you have? The same volume, 100, but the time it took him was 170. So if you do that, you're going to get 0.59 cm cube per sec. All right. So they are now asking us the relative molecular, that is A is done. So for B, they are asking us the relative molecular mass of gas X. So I know that the rate of diffusion uh, is inversely proportional to what? To the square root of the relative molecular mass. So we have that R, the square root of X, of relative molecular mass of that same X, is equal to R of O2, then the relative mass of O2. All right. So what do we have? So the rate of X, we got it as 0.59. Then the square root of R dot mm of that X is equal to the relative molecular mass of oxygen. We got it as 0.83. Then times the square root of the relative molecular mass of oxygen is 2 in bracket of oxygen is 16. So which is what? 2 in bracket of 32. So I have that what? The square root of the relative molecular mass of that gas X is equal to what? 0.83 times the square root of 32, now divided by 0.59. So I have that what? The square root of the relative molecular mass of that gas X is equal to, when you do that, you're going to have okay, you're going to have okay, you're going to have let's just do that. I have, okay, so just the relative molecular mass of this will now be everything here squared. That is 0.83 times the square root of 32 all over 0.59 all squared. Okay, so if you now do everything there, you'll be getting that the relative molecular mass of that gas X is equal to what? 63 gram per mole. Okay, that is very, very simple. So the next question, question number 5, because you know that square root crossing to the other side will become square. So that is what we did there. So the next question, question number 5 said, they said 5.0 cm cube of a sample of gas Y diffuse diffuse through diffuse through a porous partition, okay, in 120 seconds, at the same temperature and the pressure. All right, then I said the same volume of hydrogen, took 25.5 seconds to diffuse. Then I say calculate the relative molecular mass of the gas Y. Okay, so this is a very simple case. So what do we do? Solution. So first of all, we have that the rate of diffusion of gas Y is equal to what? Volume, the volume over time, which is what? 5 over 120, which is what? 5 divided by 120. But if you don't want to use this long process of getting this, we can just use their time. Okay, we will know that what? That the time of gas Y, then the relative molecular mass of gas Y, okay, is equal to the time of hydrogen and the relative molecular mass of hydrogen. Okay, so what do we do now? So this will help us to get it straight instead of getting the rate of diffusion of the gas. Okay, so what do we have now? The time is 120, so I have 120, then the square root of the relative molecular mass of that gas Y is equal to the time for hydrogen is what? 25.5, then the square root of what? That is 2 in bracket of 1. That is relative molecular mass of hydrogen. So therefore, the square root of the relative molecular mass of that gas Y will now be what? 25.5, the square root of 2 divided by 120. So therefore, when square root cross equality sign, it will become square. So I will now have that what? I will now have that the relative molecular mass of that gas Y will now be equal to what? 25.5, the square root of 2 all over 120, everything squared. So if you now do that, you will have, so where is it? Okay, if you do everything, all right, if you do everything, you have 44 gram per mole. 44 gram per mole. Okay, so we can check it. 25.5 times root 2, then divided by 120, then squared. Okay, 0.09. They got 0.09 gram per mole. So how did they get that? Is there any problem somewhere? So let me check again. So this is sorry, sorry. The time is inversely proportional. So I sorry, it's directly proportional. So I was the one that made mistake. Sorry, this is not correct. Okay, so I was the one that made mistake. We know that time, because relative molecular mass is volume over time. So time is inversely proportional. So what do we have? Is time inversely proportional? So let me check the. Mhm. It's inversely proportional. So I'm supposed to get the the result accurate. Yes, I got it. So what I did is very correct, please. Yes, what I did is very, very correct. It's very correct. Okay. So that is that for that. But that answer there is not 44. That answer is something else. So just punch it and get the result. The calculation here is very, very wrong. Okay. Uh-huh. So that is that. So the next thing we look at is the next question. Let me check my time. Okay, so let's solve one more question and then we are good to go. Question number 3 said 60 cm cube of a gas X having an empirical formula of CH3, diffuses through a porous partition, okay, in 45.2 seconds, and the volume equal volume of hydrogen took an equal volume of hydrogen took 11.66 seconds to diffuse, okay, at the same temperature and pressure. Okay, they now say A, calculate the molar mass. Okay, the molecular formula. Calculate the molecular formula of the gas. Calculate the molecular formula of the gas. B said show the structural formula. Okay, now she showed the structural formula. So if we do that, we are going to have a solution. We have that what time, the time of that gas, time of this gas X, all over what, the time of hydrogen, or time of the gas X. Okay, I want to keep it like the time of the gas X all over the time of hydrogen is equal to the square root covering everybody. The square root of what? The molar mass of hydrogen, okay, all over what? the molar mass of that gas X. So what do we have? The time of the gas X is it took it 40. So I have 45.2. I have 45.2. Okay, 45.2, or let me solve it here. 45.2 divided by the other one gave us 11.66 is equal to the square root of the relative molecular mass of hydrogen is 2 divided by, I don't know the relative molecular mass of the gas X. So this one crossing here, I will now have 45.2 divided by 11.66 all squared is equal to what? 2 over the relative molecular mass of X. So therefore, the relative molecular mass of X will now be, if you cross multiply, you will have that. In fact, it's going to be 2 in bracket of 11.66 all squared divided by 45.2 all squared. So if you do that, you will have the relative molecular mass is 30 gram per mole. 30 gram per mole. Okay? 30 gram per mole. So to calculate, they say we should calculate the molecular formula. So we know that what? Empirical formula in bracket of N is equal to molecular mass. Okay? So we have that the molecular mass is, the empirical formula is CH3 in bracket of N is equal to 30. So permit me to clean here so that I can finish it up here. Okay, so I will now have that what? C is what? That is C is 12 plus 3 in bracket of hydrogen. Then everybody times N is equal to 30. So this is 12 plus 3, that is 15. 15N is equal to 30. So my N is equal to what? 30 divided by 15, which is equal to 2. So the molecular formula will now be what? From here, the empirical formula in bracket of 2. The empirical formula is CH3 in bracket of 2, which is what? C2H6. C2H6. So the structural formula is we have 2 carbon, C2, 2 carbon, and then 6 hydrogen, which is 1, 2, 3, 4, 5, 6. So this is the structural formula. So thank you very much for watching. Please like, share, and subscribe. Please like, share, and subscribe. God bless you.